Okay, first we're going to start with a recap of what we know about exponential functions versus linear functions. So linear functions, we know the graph can look like a line with positive slope, a line with negative slope, a vertical line, or a horizontal line. So that's undefined slope and zero slope. Exponential is either going to look like exponential growth or exponential decay. And the tables, when we have a linear table, right, if we make x and y, say we have x going up by 1, then the y's are always going to be plus something, plus that same thing. Exponential, instead, is going to be multiplied by something. So if we have the x's still counting by 1, to say, then here we're going to have times something. Okay, and then our equations, so we wrote linear equations in lots of ways. Y equals ax plus b, or mx plus b. We wrote ax plus by equals c, standard form. We wrote point slope form, sorry. And there are other ways to write linear equations. For exponential, they look like y equals a b to the power of x. Okay, or you can write it in function notation, which would look like f of x equals ab to the power of x. We're going to do an example with function notation. Okay, so let's first do an example where we're going to graph. And we'll graph the function y equals 3 times 2 to the power of x. So I'm going to make a little table here just to help me. If I plug in x is 0, that's 3 times 2 to the 0 power. 3 times 1 is 3. Plug in 1, that's 3 times 2 to the first, that's 6. Plug in 2, that's 3 times 2 squared. 3 times 4 is 12. 3. Now, notice as you're looking at this table that the x's are counting by 1s and the y's are being multiplied by 2. They're doubling every time. That's because in this equation we've got 2 to the x. If we had 3 to the x, we'd have tripling every time. Okay, so now you've got to decide what you're going to count by on your axes. So here we'll call this 0, 1, 2, 3, 4, 5 for my x-axis. And here for my y-axis, I'm probably going to want to count by more than 1s because I've got to go up pretty fast. Okay, my first point is 0, 3, and then 1, 6, and then 2, 12, 4, 48. So you'll see that it grows really quickly, right? And it gives us this curve shape. Look at this. Okay. So that's one of the problems that you might have to do, is a problem like that. Another kind of problem you might have to do is where you're given a table and it asks you, is this exponential or linear? So let's look at a quick example there of 2 different tables, and we'll decide, are they exponential or linear? Okay, and just to highlight the difference, we'll start them both off at 2. Okay, now you'll notice this one, as we look at the pattern from 2 to 6, that's, well, it could be plus 4, but this one's not plus 4. So what about times? Well, this is times 3, and this is times 3, and this is times 3. This one is plus 3, plus 3, plus 3. So this is exponential, and this one is linear. Because this has a times pattern, this one has an adding pattern. Okay, let's look at one more example where you've got to, say, evaluate f of x equals 5 times 3 to the power of x for x equals 2. All you do is plug in for 2 for x, so you've got f of 2 equals 5 times 3 squared. Remember order of operations, so you got 5 times 9, and that gives you 45. So you'll write down f of 2 equals 45.